Hey guys, Miss Nguyen here with our equations with variables on both sides notes. So let's just go ahead and get started. I'm going to be doing each of these steps in a different color. That way you can really clearly see what is happening for each step. This whole first example has all of the steps on the right, so it all kind of goes together, and then I'll go through these two examples down here. Okay, so our equation here has 3x minus 6 plus 2x equals 1 plus 2x plus 2. So you can already tell right off of the bat that the difference between this and between our, the equations that we did before now, like the ones you did last year in 7th grade, is that now you have x's on the left and we also have x's on the right. So that's why we say that these are equations with variables on both sides. What it means is both sides of that equal sign. Okay? So our first step should be pretty familiar to you, because we've already done this before, but our first step is to box the like terms. Okay, so remember, first of all, that like terms have to be on the same side of the equal sign to be like terms. So before we start, I'm going to go ahead and draw a line down the middle of the equation just so you can make sure that both sides, I'll use the line tool for this. How's that? That way you can keep both sides of the equation separate. That's really important for combining like terms. That's close enough. Okay. So let's go ahead and box the like terms. So over here on the left, we have this positive 3x, remember the sign matters, and this positive, this plus 2x. Remember, these are like terms because they both have x. I'm going to go ahead and put a black box around the minus 6, just so I don't forget about it, okay? But this is not a like term with anything on this left side of the equal sign. Nothing's going to happen to this, so after we combine the 3x and the 2x, we're just going to bring the minus 6 down, exactly the way it is now. Okay, but we'll get to that in a minute. Let's look at the right side of the equation. This time we have plus 2x, but it doesn't have any other x's on the right to combine with, so I'll box this one in black to show that it's by itself. And then we have this positive 1, because if there's no sign, then we just assume that it's positive, and this positive 2. Okay, so step 1 is done. We've boxed the like terms. So step 2, you can probably guess what's going to go in this blank. After boxing, we are going to combine like terms. This is still in pink. So we're just going to, just like we usually do, take these. Okay, so this becomes plus 3x plus 2x. And remember what we are doing when we combine like terms, or just when we add x's, things with variables, is we are adding together the coefficients. So this is going to be 3 plus 2, and then we'll have an x at the end. Okay, 3 plus 2 is 5. So this becomes positive 5x. And then this minus 6 that we bring back down because we didn't do anything with it. So now this left side of the equation is 5x minus 6. On the right side, we have this 1 plus 2. 1 plus 2 is 3. Let's bring it down here just so they're all in line. 1 plus 2 equals 3. And we'll bring down this 2x that we didn't do anything with. Forgot the plus sign, so this is positive, so this is also positive. Now you could also, because I had this question asked in class, we could have also, somebody had asked me, oh, does the 2x or do x's always have to be on the left? And that the answer is no. So we could do this here. Bring down the 2x. This is plus, you see how this box says plus 2x? Just like that. So the order doesn't really matter as long as you're consistent with the signs. It's not going to affect anything. Alright, so that takes care of step 1 and 2, which hopefully should be familiar to you since we've done that previously, but now this is where things get a little different, okay? Step 3 says we are going to gather our constants. Remember, our constants are the ones that do not have variables, so just numbers by itself, or a number by itself. So we're going to gather our constants to the right by using inverse operations. In this case, with inverse operations, we're using addition and subtraction. So if it's a positive constant, we'll subtract it to get rid of it, and if it's a negative constant, we'll add to get rid of it. Okay, so we want all of our constants to be on the right because you know in the end our answer is going to be x equals a number. So we want x to be isolated by itself on the left side, and we want just the right side to only have a number by itself, isolated as well, okay? So in order to do that, we're taking these steps. So think of each of these steps as bringing us closer to x by itself and a constant by itself. And that's why we're doing it, okay? So right now, we already have 3 by itself as a constant on the right. There's no other constants here because we already combined like terms. So what we want is to move this -6 to the right, because right now it's on the left. We want them all on the right. So we need to get rid of it on the left and move it. And to do that, we're using inverse operations, right? So since this is a -6, the opposite of minus is plus. So we're going to add 6. And since we added 6 on the left to keep this equal, on the other side of the equal sign, we need to add 6 on this side as well. You're always going to be doing the same thing on both sides. I can draw this line, okay? When you have -6 plus 6, or like any negative number, when you add it to itself, like -1 plus 1 is 0, -1,000,000 plus 1,000,000 is still 0, -6 plus 6 is 0, and that's why we do this, because when we do that, that becomes 0, so now we just have 5x by itself on the left, which is closer to what we want. 3 plus 6 is 9, and then we have the 2x that we didn't do anything with. Okay, so now we only have one term on the left, still 2 terms on the right, so we're closer to our final goal of 1 term on each side. So I'm going to switch colors to green for this one. So we are gathering constants on the right, so you can guess that in this blank we're going to be gathering variables to the left, again by using inverse operations. And this is still using addition and subtraction, okay, because we are moving this 2x, but this is a plus 2x. So we're not dividing or multiplying anything yet. Do you see how there's a plus here? We're moving it by using the inverse operation of subtracting 2x. So this is very similar to when we're combining like terms, okay? So remember, when we combine like terms, we are adding or subtracting the coefficient. So same thing here. When we're doing 5x minus 2x, we're subtracting the coefficients from each other, okay? Make sure that your answer here, 5x minus 2x, still has an x on it. The x doesn't go away. You want to think about x almost like a unit, okay? Like, let's say I have 5 cookies, and Daniel, because he's greedy, takes 2 of my cookies. Well, I have 3 cookies left, right? The cookies didn't go away. 5 cookies minus 2 cookies isn't just 3, it's 3 cookies. So you cannot drop the x. I see a lot of kids do this, and they'll drop the x, and then they have like 3 equals 9, and then they get confused, okay? The x is still here. We're only subtracting the coefficients. Then of course over here, 2x minus 2x is 0. We still have the 9. Okay, so our very last step, I'm going to do this in purple. This looks just like our one-step equations, right? So we only have one step left to do to get x by itself. Well, we need to get rid of this extra baggage right here. And remember, what is the vocabulary term for a number that's attached to a variable, like a number being multiplied by a variable like this? This is a coefficient. So we are going to remove the coefficient by multiplying or dividing. Like I'm going to tell you about 99% of the time we are going to divide to get rid of it. Every now and then you get something kind of like our old practice problems, like it'll look like that. And you'll have to multiply, but most of the time you will divide as your very last step. So we want to, because this is 3 times x, that's why we're dividing to get rid of it, because dividing is the opposite of multiplying. And since we divided on the left, we have to also divide on the right. This turns into 1. That's why we have x by itself, because when you have a 1 as your coefficient, we don't write it. So that's why dividing this by 3 turns this into just x by itself, because it's really a 1x. And then 9 divided by 3 is 3. So that gives us our answer. So compared to our 1 and 2 step equations, this really just has the extra step of combining like terms and moving variables. Because before you would only have to add or subtract a constant and then you would just divide or multiply. But this time you have to also gather the variables together because we have variables on both sides. So you have 2 steps where you have to add and subtract. So this step right here of gathering the variables, this is what really makes this different. So this is a very important step, that you do not want to divide until the very end. When you have one term on both sides, then you divide. If you still have 2 terms like we did over here with 9 plus 2x, you shouldn't be dividing yet. You should only divide when you have 1 term on both sides. Okay, so now let's look at an example number 1, and we're going to run through these same steps but a little bit quicker since now we're used to it. So step 1 and step 2 is to box and combine like terms. I'm going to draw this line down here. That is a really wonky line. I need to just use the line tool from now on. I don't trust myself. Alright, there. So we're going to box and combine like terms. So over here we have this 3x and this 5x and this negative, or this minus 7 here. Then we have 11, 10, and 4x. So you'll see that the setup of this problem looks really similar to the one we just did. So maybe if you would like to, you can pause right here, try it on your own, and see if you get it. Because maybe you just picked this up really fast, who knows. Okay, so time to combine. Alright, so now I have combined like terms and simplified my expression to be 8x minus 7 equals 21 plus 4x. Right, you can see how we combined our like terms there. Okay, so our next step is to gather constants to the right. So we need to move this over to the right side. We're going to, this is a minus 7. So the opposite inverse operation is to add 7, which means I'll add 7 over here too. This becomes 0, goes away, so we have 8x equals 21 plus 7 is 28 plus 4x, which we bring back down, we didn't do anything with. So our next step, gather variables to the left by using inverse operations again. So add or subtract. That means we're going to move this over there. So this is a positive, oh, I should have boxed this whole thing. Here we go. This is a plus 4x. So we'll do the inverse operation and subtract 4x. Like, you see how this is lined up? You always want, when you're doing your inverse operation, these two signs should be opposite. So if you have a plus here, then you have a plus here, then you know you did something wrong. Okay? So this is plus, so this should be minus, which means we'll also minus 4x from the left side to keep it equal, right? Remember, our equations are like a set of scales. So if you add something to the right side of the scale, you have to also add it or subtract it to the other side of the scale, otherwise the scale won't be balanced anymore, right? Now this goes away. So we're left with 28 here. This is 8x minus 4x. You kind of want to think of this, remember, as 8 minus 4 and x. The x is still going to be there. Don't drop the x. 4x equals 28. Last step, divide to get rid of this coefficient. So our answer is x equals 7. Okay. Last example. I'll go even faster now. Okay, so we have minus 6x minus 5x on this side. I forgot to draw my line. Okay, what do you notice about the right side of the equation? There's no more like terms over here, so I don't have to box anything. I guess if you really want to, we can just do the black boxes over here just to show that these are not like terms. Oh, that's confusing. I'll use different colors. How's that? You really want to color code your boxes because it makes it easier for you to tell what are like terms and what aren't. Now, make sure, like double check after you've drawn your boxes that everything in the same colored boxes has the same variable. Because I've seen you guys do this sometimes where you have the boxes, but then you have a box that doesn't quite belong. So double check once you've made your boxes. Don't just think, oh, I'm good, I finished my boxes, time to move on. Like, you should be checking yourself at every step. Okay, well now that means we don't have anything to combine on the right, but we have two sets of things to combine on the left. Negative 6x minus 5x. This is negative 6 minus 5 with an x. Okay, if you are not very good with negative numbers, this is where you can open up your Desmos calculator. Negative 6 minus 5 is negative 11. This is very important. A lot of you missed this step. If you already know you're not good with negatives, or just to be safe, even if you feel like you're good with negatives, just use your calculator. Don't guess. This becomes negative 11x. 3 plus 6 gives us 9. This is a positive 9, so that means when we bring this down, it's plus. Then over here on the other side, we just have 45 minus 2x. Didn't do anything to them because there's nothing to combine. Okay, now we have our simplified equation, and we can start solving it. So our first step is to move constants to the right. So we need to get rid of this 9. It's a positive 9, so I subtract. Okay, now we're going to gather our variables on the left, so that means this negative 2x, this is on the right, so it needs to go to the left. This is minus 2x, so we will add 2x. This goes away, so we have 36. This you want to think about as negative 11 plus 2, right? Because we are really just adding these coefficients here. Negative 11 plus 2 gives us negative 9. And then we don't drop the x is still there. So now we have negative 9x equals 36. So we are going to divide, oops, forgot the color change. We're going to divide both sides by -9. $36 divided by -9 is -4. Now we're done. Okay, so the rest of these problems are your independent work that I will be checking. And then, of course, the last page, you need to summarize the lesson. This is really important for the notebook check, so please make sure you write a couple sentences here to talk about what you learned from this. And that is really about it. Hope this was useful for you, and I will see you guys in class.